Hello, students. I'm in this old field to see if I can find the state bumblebee, the rusty patch bumblebee. It used to be quite common, but now its numbers have decreased precipitously. The rusty patch is pretty easy to identify. It's a small bumblebee, and on its abdomen, the back half, it has a reddish-brown patch. And what are you doing here, sir?
Hi, I'm actually out here trying to capture some of the bees and butterflies that are frequenting this area.
Oh look, here's my neighbor Tom Klein with the Minnesota Biological Survey. What's going on, sir?
Well, I'm looking at native wildflowers searching for the elusive rusty patch bumblebee, which is the state bee of Minnesota. Up until about 20 years ago, they used to be found all over Minnesota, but since that time, their numbers have crashed.
So they're actually endangered?
They're actually endangered in the state and in the whole country. Across their whole range in the upper Midwest, their numbers have been declining rapidly.
Well, today's show is about pollinators and coevolution. So we just saw a little bit about the bee. That's a great pollinator. But what's coevolution? So first we have to break it down. What's evolution? Well, depending on where you are in your science education, you may not know much about evolution, or you might know quite a bit. But briefly, evolution is organisms changing over time. And as they change over time, they're becoming better suited for their environment. So they're evolving or changing. When we use the word co, it means together. So if you're a co-captain of a team, you're a captain with somebody else. You're both sharing that. Coevolution would be two organisms evolving together. A change in one organism can bring about a change in the other organism. So we're going to be looking more into some examples of coevolution. It'd be helpful to remember some of the relationships you probably have studied, such as mutualism, competition, predator-prey, commensalism, parasitism. The ones we'll be focusing on today will be mutualism and a little bit of competition. Pollination is a great example of a mutualistic relationship that can cause changes in both the pollinator and the flower getting pollinated. Over time, the flower becomes better adapted at attracting the pollinators through strong smells that attract insects, or through their bright colors, or providing a super high energy food called nectar, or specialized markings that are adapted to the insect's eye. For example, these flowers appear yellow to you and me, but when seen through the eye of a bee that can detect ultraviolet light, you would see the markings on the right that would direct the bee precisely where to go to find the nectar and to also pollinate the plant. Take a look at how the shape of this spotted jewelweed is perfectly matched to the size of the bumblebee's body. The bumblebee actually has to work very hard to get into where the nectar is. And when it does so, it will come in contact with plenty of pollen, and it will also be dropping off pollen from other flowers at the right flower parts, the female flower parts of the flower. When you see a pumpkin this fall, think a bee. So let's take a look at a pumpkin plant. These bright yellow flowers are very attractive to bees. There's one bee in particular called the squash bee. It's a native bee in Minnesota, and it has long antennae. The female will make a nest in the ground near the squash plants. The male bee, though, is solitary. It lives on its own. Where does it find a home? Well, at night, the squash flower closes and opens the next morning. The male bee often will go into the squash flower in the evening and be closed in for the night. When I squeeze it, the bee starts buzzing. You can hear it inside there. Let's take a look. Red is a particularly good color for attracting hummingbirds. Most hummingbird feeders are red. So students, this is one of my favorite stories of coevolution. This flower is the cardinal flower, and it has evolved with the hummingbird, which is its pollinator, and it's perfectly adapted to that. Let's say this is a hummingbird. It will come in to get the nectar. It inserts its beak down to where the nectar is, and this part of the flower is where the pollen is, and that will brush the top of the hummingbird's head, and as it flies over to the next plant, that pollen will come off on the female portion of the flower, called the pistil. So, hummingbird head, perfectly adapted, flower perfectly adapted, and so together they're helping each other. The flower provides the nectar, and the hummingbird transfers the pollen from one cardinal flower to the next. Here is one of my absolute favorite examples of coevolution. So when you see a mushroom sticking out of the ground, that's just the tip of a fruiting body of an organism that extends for many acres underneath the forest floor. But they also connect to the tree roots. The tree gets its nutrients from the fungus, and the fungus gets sugars from the tree. This is a mutualistic relationship. They send out little roots called mycelium, and they intertwine with the roots of trees. And trees actually can send messages, chemical messages, from one tree to another, sometimes on the opposite side of forests. Scientists sometimes refer to this network as the wood wide web. It's a way of communicating that we've just recently learned about. Let's say at one end of the forest there's an invasion of insects. Those trees under attack can send a message to trees throughout the forest via the wood wide web and let them know that it's time to start making chemicals that will help them defend against the insect. Who knew that underneath the forest floor was an internet of trees? On one of my visits to Cedar Creek, I got to visit with Maggie Anderson, a PhD student who's studying prairies. I asked her if she had any good examples of coevolution. This is what she said.
So I have an example of a relationship that I study that might lead to some coevolution happening. So what we've done is we've warmed up this prairie in the experiment that I work on, and this plant right here is called big bluestem. It's a really super tall plant, and we know that it does really well in warming. In fact, it actually crowds out other species that might also be trying to get light and nutrients and other things that plants need. And so this is an example of competition where this big bluestem species is actually outcompeting these other smaller, littler species that don't like it when it's hot.
What's wrong with one species being successful? This is America. We reward success. But no, seriously, what is the why is it a problem if one species? It is a prairie plant.
It is a prairie plant, and it's a native plant.
And it's a native plant.
So it's not like an exotic species that was brought in by humans. Yeah, the problem with this is that if you have one species that becomes really competitive and starts taking over, it can actually lead to extinction of other species that aren't as good at surviving, maybe under warmer conditions, or maybe just in the presence of this really good competitor. And so we want to have a lot of biodiversity, we want to have a lot of species. And so this plant taking over and being a good competitor might not be very good for that. So as a little kid, I really loved to be outside, and I was really lucky in that my parents took me on all sorts of canoe trips and hiking trips when I was little, and so I've always really loved to be outdoors. And I was trying to think, okay, what's a profession where I can be outdoors all the time? And I get to be a field ecologist. So I spend a lot of my time outside in prairies taking measurements and making observations. And so I When I got into high school and college, I started taking science classes and I started learning more about the natural world around us. And I discovered that I was really interested in how climate change was going to affect the outdoors and the nature that I really loved in the future.
So how long from now before I call you Dr. Anderson?
Hopefully 3 to 4 years. The whole program should take 5 years, and it depends on how quickly I can get data and how good that data is.
Okay, well good. All right, well good luck.
Thank you.
All right, thanks for your time.
Yeah, thank you so much.
Well, that's our show on coevolution. It's a beautiful day in the nature. Oh,
crap.
oh, sorry. No, that's quite all right. Episode 4 is next week.
Next week.
Okay. Well, hey, before you go, what is episode 4 going to be about?
Episode 4 is going to be all about rivers.
Okay. Say hi to Mom.
Okay, I will.
I like the
And
shirt.
by the way, I like your shirt.
Oh, thanks.
This whole
See
time.
you later. So that's it for this week. He'll see you next week. Until next time, have a beautiful day.